Graph in practical situations, those are mostly speed time graph, like travel graphs. So you may have speed against time, acceleration against time, or distance against time. The diagram shows how to convert miles into kilometers. Use the graph to find the approximately how many kilometers the same are same as. Okay, so if we are using this graph, we can see that 25 miles on x-axis, kilometers on y-axis. So I'm looking at 25 miles on horizontal axis. This is 20, 30. So this is 25. Against 25, I get to see that this is 40 kilometer for 15 miles. This is 10. This is 20. I'm looking at 15. And from my graph, I try to read. So I guess that's 22. What do you say?
Yes, sir.
Maybe this is, I would say 24. I would say this is
25.
24 because this hole is 10. So if we make five small boxes, 24. In exam, we would have those millimeter marks as well. Against
45 is
45.
around 60s. One.
No, 45.
Yes,
45
yes,
is between
45.
these two. This one is 45.
Yes, sir, yes, yes, sorry.
So this is almost 72.
72, yes, sir.
And then 5 miles,
It will be 8, 9.
8. Now, I got these two values. First of all, we'll be able to read the graph exactly because in exam we do have millimeter mark graph. And I also use this as the ratio on uh, on the back, like 25 miles were giving me 40 kilometers. So when I was checking for 15 miles, I just did unitary method and got the exact value 24. Same graph, use the graph to find approximately how many miles are same as 64 kilometers. So kilometers are on y-axis, 50, 60. The midpoint should be 65. So 64 is somewhere here and it hits this mark, which is 40. Then we have 56. Using the same graph, this is 50, mid is 55, slightly above the 55 mark, and it hits this point, giving us 35. Try 16 kilometers. 10, 20 in between is 15, slightly above that. What do you think?
So
16 kilometers, how many
so
miles?
16 is 10.
16 is 10.
10
And
is
then 32, double of 16 is 32.
32,
Double of 10 should be 20.
20.
But from the graph, we should get this value as well
Yes,
as 20. So interpreting graphs. Okay. The first time Tim went to Paris, this graph showed him how to convert pounds into euros. You must have went through this in real life as well. Money exchange, conversions. So use the graph to find approximately how many euros were the same as 20 pounds. Pound is on x-axis. This is 20. Against 20, I go there. This is 24. So that's Let me recheck. I'm also checking it by unitary method. This is 140. This gives it the exact intersection and against 100. So 140 divided by 100. 1 pound is actually 1.4. So multiplying 1.4 with 20 to get 28. So against 20. Yeah, that should be 28. I misread it with 10. The last graph was actually 10. I misread it with 10. So 20, this much gap, this midpoint is almost 30. A little below than that, this is 28 euros. And then we have 80. At 80, this is a little more than half. So 110, a little more than that is 112. Try 50 pound.
Okay, sir. 60, 70, 70.
70.
Yes, sir.
Use the graph to find approximately how many pounds were the same as, so same graph, and let me change the color.
And says 56. So this is
56 euros. So
uh,
on y-axis, 56 euros to pounds. This is 40.
40.
Mid is 50. Somewhere here, oh, okay, yes, 40.
Yes, sir.
Then 84.
84 will be
This is 90. This mid is 85. A little
60.
less than that, 60. Yes. And then 140.
40 will be, oh yeah, 100.
That is 100. Okay. Tim spends 154 euros on clothes in Paris. How many pounds did he spend? So 154. This is 140.
Yes, sir.
150. 154, slightly above that. It should strike at this point. So 154 euros is, this was mid was 150. This mid again is 155. A little below that is 154. So this is 110 pounds. Number three, a company hires out vans at a basic charge of $35 plus charge of 20 cents per kilometer traveled. Copy and complete the table where X is the number of kilometers traveled and C is the cost dollars. Draw a graph of C against X. Okay, first thing, company hires out a van at a basic charge of 35. If this is a fixed charge, Y is equals to MX plus C, we would know that even the distance is not there, company would charge $35 and then 20 cent per kilometer. I'm changing that into dollars to have same units is $0.2 per kilometer. So gradient is zero point 0.2 and X is number of kilometers and Y is the total fare. Does this thing make sense? If we have to draw the graph, it is clear that y-axis, x-axis, and we know that this is 0, 0 on both sides. Let's say this is 10 kilometers, 20 kilometers, 30 kilometers, 40 kilometers, and let's say this is 1, 2, 3, 30 and $40, 20 and 10. Let this be dollars, let this be kilometers. So according to the given information, there is $35 fixed charge. So in between these two, this is 35. Now the company is charging 20 cent per kilometer. So for 10 kilometers, 20 into 10, company would charge 200 cents. That means $2. So at 10, this was 35. So we mark at 37. And then at 20, two more, 39. At 32 more, 41. So we will have this line, and we can use the same graph to find the missing values. Like at 50, so on horizontal axis 50, we would just go there and find. Any issues in understanding this?
Mm, no, sir.
So I'm getting 45. I do not have graph paper and exact straight line. So I'm also using unity method on calculator. But you can just plot 2 points. For example, it would be better that we do for 100. So 20 cents per kilometer. So if I do for 100 kilometers, that is 2000 cents divided by 100 again is $20. So first was 35, and 35 plus 20 is now 55. So it would be easy to 50, 60 to mark 55 against 100, 50, 60, 70, 80, 90, 100. So 100 and 55 mark. This is that. So we can join this 35 mark and that 55 mark from 0 to 100 kilometers. Now we can use the straight line to interpret. And we do have graph till 300. So we can go beyond. And this is actually extending a lot. So we can make changes and just say that this is like, for example, let's say 4 boxes are 100, another 4, 200, another 4, 300. So 50, 150, 250. Equal splits accordingly. So 100, at 100, it is 55. At 200, I'm just using that equation we just wrote, is 75. At 250 is 85. Use the graph to find the number of miles traveled when the total cost is $71. So that would be easy. Again, just go to our graph, and 71 is on y-axis. This is 70, this is 71. So against 71, we can go and read how much distance is covered. For now, I'm using the same equation. I'm substituting 71 in y. So 71 minus 35 divided by zero point 0.2, and I'm getting 180. So 180 kilometers was traveled. I write down the formula connecting C and X, already did. So from the graph, definitely you would find the equation of the line. Number 4. A car travels along a motorway and the amount of fuel in its tank is monitored as shown on the graph. How much fuel was bought at the first petrol station? So this is fuel in the tank and distance in kilometers. Okay, solve this part. Many liters of fuel were bought at the first petrol station? Any ideas?
So we will do 15. No,
See,
no way.
distance 0 kilometers and the fuel is already 15. So they started traveling
30.
30, yes. So they're just traveling, and at this
Yes,
point,
sir.
they stopped and refueled.
Yes, sir.
So from 5 to 35, 30 liters. Okay.
So this
What
is
was the kilometer per liter before the first stop?
10 liter per
So they're consuming 10 liters in 9
80, 80
kilometers.
gram.
1, 2, 3, 4, 5.
So 20,
Yes,
40, 60, 80.
80. So 80 in 10, that is 8 kilometers per liter.
Yes, sir. Yes, sir.
And between the two stops,
This would
these
be
are the two stops.
yes, sir.
What was the average fuel consumption over 200 kilometers?
We will take the total
Total
fuel
distance, right?
and
And what is the total fuel consumed?
uh, 10 plus 30 plus 40. So 10 plus 30 plus 40. Um, 10 plus.
See, they first consumed this much, that is 10.
Yes, sir. Then
They again
uh,
consumed this much. This is 20, so
yes, sir.
total 30.
20. Yes, sir. So,
So what average? This is 6.66 kilometers per liter, or 6 2 by 3 kilometers per liter. After it leaves the second fuel station, the car is stuck in slow traffic for the next 20 kilometers. Its fuel consumption is reduced to 4 kilometer per liter. After that, the road clears and the car travels a further 75 kilometer. During the time, the consumption is 7.5 kilometer per liter. Draw a copy of graph and extend it to show the final 95 kilometers of the journey. Okay. So slow traffic, they're saying that for next 20 kilometers, this is 4 kilometer per liter. So what would we do? This is 200. This would be 220, and 4 kilometers in 1 liter. 4 kilometer and 1 liter, and this is 20. So 20 would be x liters. That is 5 liters. So basically, from 45 to 40, it would drop from 45 to 40. Done. And second half says 7.5 liters are consumed in the next track per liter. 7.5 kilometer per liter. I'm multiplying it with 20 again because one box is for 20. So 7.5 into 20. Sorry, 7.5 is already distance. I'm looking for a good stop like 7.5 and 7.5 will be 15. One full box and one half box. Let's say this is one full box, and this is the midpoint. So basically, it would cover 15 in 2 liters Let me check for 5. 7.5 into 5 is 37.5. So 220 to 40, 220 plus 37.5. I'm getting 257.5. So 40, then 50, and then 260. So between these, we would just put a point against that and draw the line. This would be a little less steep. Any confusion in this?
No, sir.
D says how much fuel is in the tank at the end of the journey. So whatever the point will be, we'll just read it from the y-axis. We can also calculate it manually, like just consuming 7.5 per liter. So 75 divided by 7.5 is 10 liters. So consuming 10 liters, 40 minus 10 is 30. So there would be 30 liters. Okay. A firm makes a profit of $1,000 from producing X thousand tiles. This much dollars from this much tiles. Corresponding values of P and X are given in the table. 0 tiles minus 1000. Definitely that is the running cost. 0.5000 tiles, that is 500 tiles, and this much, 1, and so on. Using a scale of 4 centimeter to 1 unit on x-axis, draw the graph of 4 centimeter to 1 unit on each axis. Okay, let's do this. I'm using the same grid and trying to draw as neat as possible. Let's say, so 4 centimeters, 4 times is 12. So I would at least need 12 boxes on each axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And x-axis again 12 boxes. 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12. So 4 centimeters to 1 unit. Let this be 1, 2, and 3. This is 1, 2, and 3. So x starts from 0 and p starts from minus 1. Oh my god, I needed 4 boxes to left as well. Let me move this. Okay, 1, 2, 3, 4. So this is minus 1 and so on. Now let's just plot them. X0, y minus 1. This was needed. X0, y minus 1. X is zero point 0.5, y is 0.75, x1, y2, x 1.5, y 2.75, 1.5, 2.75, x2, y3, x 2.5, y 2.75, 2.5 and 2.75, x3 and y2. So number of tiles are increasing and the profit is actually decreasing. The number of tiles. Okay, now let's just first draw the curve and then move. to the next part. Okay. Net says use your graph to find the number of tiles the firm should produce in order to make maximum profit. Number of tiles are on x-axis. Profit is on y-axis. What do you say? Maximum profit, how many tiles should they make?
Uh, okay. Okay.
Hmm. That is straightforward.
Yes.
Can you see the maximum profit, the highest value the graph is reaching?
Yes, sir. Bridge 3.
Yeah. So the highest profit is at this point 3, and how many tiles? It is 2000 tiles for maximum profit. And
Yes, sir. 2000.
use a graph to find minimum number of tiles that should be produced to cover the cost of the production. To cover the cost of production.
Minimum. So this one,
To cover the cost of production. What does that mean?
like to like not go in loss.
That's right. That means break even.
Yes,
So
sir.
break even means zero profit, no
Yes, sir.
loss, no gains, but zero profit.
Yes, sir. So,
So zero profit. This is 0.25. 0.25 times 1000.
yes,
So they should make minimum 250 tiles to cover the cost of production.
0.5. Yes, sir.
Try C part.
Not the values of this. Zero and the profit. So when x is 2,
Okay, let me just mark that. This is
2,
2850 means 2.85.
yes, sir.
This is 2.5, 2.75. This is 2.25 and 0.25. If I make 5 equal divisions, that would be 80 and then 85. So roughly, need to draw the horizontal line. Roughly at this point, so the range of x for which the profit is more than this. So we have these two values, 1 and 2. When the number of tiles are between these two values, profit is more than the given number. And I think that is 1.5, 6, 7. 1.7? 1.7 to 2.3 or 1.752. 1.7 to 2.3. What do you say?
Yes, sir.
Okay. Leaving this last question for practice, let's see what we have in next exercise. Representing linear inequalities graphically. Now we already know we've done sketching. When they say x is greater than equal to 2, I would read it as x is equal to 2 to draw that line. If I have this x-axis and y-axis, x is equal to line at 2. Then y is equals to 1 is a horizontal line at 1. Y is equals to 5 is horizontal line at 5. And x plus y is equal to 8. I'm making y the subject. Y is equals to minus x plus 8. I can see the gradient is negative and y-intercept is 8. So it would just intersect at 8 and negative gradient. I'm substituting x is 0, so I get y8. When I substitute y0, I get x as 8. So intersects at 8 on x-axis. So this is how we draw the lines. And then these are inequalities. It says leave unshaded. Whenever you attempt a question for inequalities, do read this carefully. Sometimes it says shade the required region. Sometimes it says leave it unshaded. So x is greater than 0 is definitely the region on this side. So we leave this unshaded. So we shade the other part. Similarly, y is greater than 1. So we don't shade this. We shade the other part. Y is less than 5. So we don't shade this. We shade the other part. Getting it? And whenever we
Yes.
have both of them, x and y, both of them, you can always ignore x. So y is less than 8 means this is below the line. This is the line, this is the region above, this is the region below. So when it is below, but the question says leave that unshaded, this is our region, so we are leaving it unshaded and shading the other part. Okay. Now those were inequalities and we had to shade. Now these are already shaded and we have to write the inequality. First of all, it says describe the region left unshaded. Unshaded. So this unshaded is x less than equal to 3. Would you agree? X less than equal to 3. Yes or no?
X equals
If you are slightly
mhm,
confused, you can also write that this was 3, 2 and 1. So what is this region? Is it less than 3 or
mhm,
more than 3?
3.
Values 1 and 2 and 0. This is less than equal to 3.
Yes, sir.
And see the difference between less than equal to and only less than. When we have solid line, we write less than equal to. That means that value is included. And when this is not included, this is only x less than 7. When this is not
Yes.
included, this is only y less than 5. Try question number 2. Sign of inequality.
Mm,
Less than or greater than.
Sir, mm, is greater or it's
Correct.
great.
Unshaded region is above the line, so it is greater than equal to.
Yes, sir.
Try number 3.
X 1, 6. It's greater.
1, x is greater than equal to 1. And the next one, 6.
Yes, sir. 6 will be X will be uh,
See this unshaded region, unshaded part, which is left unshaded. Is this more than 6 or less than 6?
Some less than
If you
6?
write these numbers, this is 5, this is 6, this is 7, this is 8, this is 9. It increases on right, it decreases on left. So
Less
this
than
is
6.
before that, so that is less than equal to 6.
Okay, sir.
If we had to write it as one inequality, we can also write it like this because it is between these two numbers, 1 and 6.
Okay, sir.
Try number 5.
Why is so it's same with y is equal to x, so it's same.
See, this is y is equal to x. This is our favored region.
Yes,
Is
sir.
above this line or below this line?
It's above.
It's above the line. And I told you, whenever we have x and y both, we can always ignore x, right?
Okay, sir.
So the region, I'm looking at the region and I'm favoring y. So if the region is above the line, y is greater than whatever is on the other side.
Okay, sir. Yes, sir.
Similarly, you look at question number 6, the region is below the line. So I'm looking at y only. So x plus y, I'm looking at y only. Y is
Yes,
less. Now this is dotted line. That is why we are not putting equal to sign. This is only less than.
yes, sir.
Okay, one more, question 7. Start with the horizontal and vertical lines first. First this line. Y minus 2. What should be the sign?
It will be y will be greater,
Correct.
greater.
Y is greater. And now this vertical line.
That will be x will be what do you call less than
Less than correct.
this.
And the slant line.
This will be y is equal to greater. Y is greater. Or
See, this is the line. Is the white region, the unshaded region above
yes,
this line?
yes.
This line?
Sorry, yes, sir. Y will be less.
Lesser.
Yes, sir.
Okay, so do practice the remaining questions. One question from the previous exercise and few of these. Okay, now these were already shaded and equations were being asked. These are the inequalities and you have to sketch them. And
Yes,
we have done sketching in the second last exercise. So do practice that one question.